Hello everybody, welcome to section 1.1. This section covers real numbers. This should be a lot of review for most of you, but if it's not, don't worry too much because we will go over it. So first off, the real numbers have a kind of anatomy to them. So there's different parts to the real numbers. The first and the most basic part to them are what we call the natural numbers. These are also called the counting numbers. So they're 1, 2, 3, etc. So if you had a bag of marbles, for example, and you wanted to count them, these are the numbers you would use. Containing the natural numbers, this box in blue here, are the integers. The integers are all the natural numbers, plus things like 0, and all the negative numbers. Cool. Pretty basic. Containing both of those in red here, like that, are what we call the rational numbers. The rational numbers are any number that can be expressed as a fraction. So it contains the integers and the natural numbers because you can express those as fractions, right? So if you take 3, for example, you can just write it as 3 over 1. That's a fraction, and it's just equal to 3. So all the natural numbers, all the integers, those are rational. It also has things like, simple fractions like 1/2, or weird ones like 13 over 42. It also has decimals like 0.17, because you can just write decimals as like this. So for example, this one becomes 17 over 100. So it's a fraction. So decimals are rational numbers. Cool. Separate from all of those, actually, is in this yellow box, irrational numbers. These are numbers that can't be expressed as a fraction. Some of the more famous ones are, for example, pi, or e, or square root of 3, etc. And there's a whole bunch of irrational numbers. In fact, there's infinitely many, but they're completely separate from all those rational numbers. And altogether, these make up, in the white here, the real numbers. Cool. So those are the real numbers. And if we have real numbers, we can combine, oops, don't know what I'm doing here, combine real numbers with things like addition, subtraction, multiplication, and division. So I'm going to go over a couple rules for how we can combine real numbers. So properties. All right, so you've probably heard of a couple of these before. The first one is commutativity. And commutativity just says that things can move around, right? So for example, if we have A plus B, that's the same exact thing as doing B plus A, right? And if you want to see this in numbers, 2 plus 3 is exactly the same as 3 plus 2. So it doesn't matter in which order you add. Similarly, A times B is the same thing as B times A. So 5 times 7 is the same thing as 7 times 5, right? So it doesn't matter in which order you multiply or in which order you add. Cool. The second important property is associativity. There should be an A there. Okay, cool. Associativity is a little funkier, but it looks like this. So you can do A plus B first and then add C, but that's exactly the same thing as doing b plus c first, and then adding a here. Like that, right? And so in numbers, this kind of looks like 3 plus 7 in parentheses plus 2. That's exactly the same thing as doing 7 plus 2 first, and then adding 3. Same thing with multiplication. So if you do a times b times c, that's exactly the same thing as doing a times b times c. In numbers, this looks like 3 times 7 times 2 is equal to 3 times 7 times 2, right? So associativity, pretty basic. You don't really want to go anywhere without it. It's very useful, actually. But the last one, which will probably be the most useful for you, is distributivity. Distributivity kind of looks like this. So if you have A times B plus C, what we can do is we can distribute the A inside the parentheses, like that. So, and that then becomes equal to A times B plus A times C, right? If you've taken an algebra class before, you'll probably recognize this as one of the kind of key components of FOILing, which we will cover later. So it also works kind of the other way. So you can do A plus B and then times C on this side. And then the C gets distributed in, oops, like so. And then you get A times C equals B times C. Oops, not equals. Bah. Plus B times C. There we go. Cool. So those are like the basic properties of how you combine real numbers together. Now, this next section is going to be like a review of some basic fraction arithmetic. This should be pretty common knowledge, but I'm going to go over it anyway just to get all the bases covered. So, review. For example, if we wanted to add 3 over 20 plus 7 over 60, how do we do that? Well, to add or subtract fractions, we need to make sure they're over the same base, right? So this 60 here and this 20, they don't match up. So we can't just go ahead and add 3 plus 7. We have to do a little bit of voodoo trickery here. So the way we're going to do that is we're going to look at the LCD, the lowest or least common denominator, between 20 and 60. And actually, 60 is equal to 20 times 3. So their lowest common denominator is actually just 60, which is good because we can take our fractions here. So we had 3 over 20, and what I'm going to do is I'm going to multiply it by 1, but a fancy one. I'm going to multiply it by 3 over 3. And where did I get that number from? From this right here. I took this number and put it over itself. And I made it over itself so it's multiplying by 1. So we're not actually changing this fraction. We're just kind of re-expressing it. And then that becomes 3 times 3 over 20 times 3. And then, oh, look, it's 9 over 60, which is good. That's what we want, because now if we go back and look at our original equation, we can replace 3 over 20 with 9 over 60 plus 7 over 60. And then we can do 9 plus 7 over 60 because the bases are the same. The denominators match up. And then that becomes 16 over 60. Good. Perfect. There's also cases where you're going to need to simplify fractions. So if we have simplify, let's say 16 over 60, just kind of in a 60 mood today. How do we do that? Well, what we're going to do is we're going to take 16 over 60, and we want to find common factors. And just one will do for now. So we notice both are even, right? 16 is even, 60 is even, so 2, they're both divisible by 2. It's a common factor. So once we have a common factor like this, we can go ahead and use it, because we know that 16 is 8 times 2, and then 60 is 30 times 2. And so we can write 16 over 60 equals 8 times 2 over 30 times 2. And then these 2's cancel, and we end up with 8 over 30. Cool. And now we want to go ahead and look for common factors again. You notice once more that both of them are divisible by 2 because they're both even. And we could have done this, yes, in one step by looking at just 4, but this is also perfectly fine. And so 8 is equal to 4 times 2. 30 is equal to 15 times 2. And so then we can write 8 over 30 equals 4 times 2 over 15 times 2. These 2's cancel. And then we get 4 over 15. And then 4 here only splits into 2 times 2, and then 15 is 3 times 5. And they don't have any common factors between them, so this is reduced. Good, cool. So that's how you simplify fractions. We're going to move on now to a slightly different topic. I'm going to define a new term here. Let me do this in green. So, new section, definition. A set is a collection of objects called elements. So you can think of a set as just kind of a box, and you can kind of put whatever you want into this box. So for example, this is how you write sets. It's curly bracket to start the set, and then you put the things you want in the set in between the curly brackets. So let's say we do 2 and 3 and 5, and then we go ahead and close it off, right? And then this is a set. Oops. A set, right? There are ways to write more complicated sets called set builder notation. The way this works is you have a curly bracket, and you sort of write like the broad category of thing you want. So I can just have the variable here, x, and then you do a bar. Some people use a colon, but I like a bar, and it means such that. So you have x such that x is a real number, and let's just do x greater than 5. And then you close it off with a curly bracket. So you can build complicated sets this way by sort of outlining the broader category here, and then over here, the conditions for what goes in the set. And that's super useful. What will be more useful to you is interval notation. So intervals describe sections of the real line. For example, if we draw a number line, like so, and put some tick marks on it, and let's say we have like a section of the real line that kind of looks like this. Let's say we start at -2, and we want to include -2, and then we stop at 1, we want to include 1, and we want everything in between. So how do we describe that with numbers? So we use set builder notation. So the way this works is, because we're including the endpoints, we get a bracket, and it starts at -2, and it goes all the way to 1, and then 1 is included, so we get another bracket. Cool. You can also use parentheses with these. to denote not including the endpoints. So if you have, say, open parentheses, 0 to 3, and then parentheses again, on a number line, this looks like 0, kind of like this. So you start at 0, we're going to do an open ball because we're not including the endpoint, and then 1, 2, 3, open ball, and then squiggle in between. And that is this one right here. Cool. Now, you can combine intervals in a pretty neat way. So, to combine, we have two symbols we use. We use a U, which is for union. That's kind of to add them together in some sense. You kind of throw everything that's in both intervals into your set. And then we also have an upside down U, which stands for intersection. And it's kind of like subtraction. And a way to visualize these is if, let's say we have this set here, A, and then let's draw this set here, B. Everything that is in their intersection is here because it's in both of them. But everything in their union is all of it. Everything in A and everything in B. So that's union. So what does this kind of look like for us, for interval notation? So for example, what if we had this 0 inclusive to 3 and then intersect open interval 2 to 4? How do we figure out what does that look like on a real number line? Well, let's just do it piece by piece. So if we look at the first one, the 0 to 3, we draw a real number line, get some ticks on it. We'll just depict this real quick. So it starts at 0 inclusive, so this gets filled in. And then 1, 2, 3 filled in because it's bracket. And then everything in between that. And then let's look at the second one real quick. 0. So we start at 2, open ball, because it's a parentheses, and then to 4, closed ball. And so intervals can be open on one end and closed on others, and then everything in between. And now if we look at, because we're doing intersection, we want to look at like their overlap, right? So what this becomes, if we draw their overlap on a real number line, so 0, what this looks like then is, so this endpoint here, not included in the 2 to 4 one, so it's not going to be included in the intersection. And then this endpoint here, this endpoint here is included, and it is at 4, or sorry, 3, my bad. And so that's filled in, and it's just this little part in between them. And so this is the intersection. Cool. What does looking at a union look like? Let's see. So like depict, let's do, oops, that's a ambiguous thing right there. Depict bracket, -3 to -1. Let's do parentheses here. And then union, and I'm just going to do a set, a little point. So the way that looks like is curly bracket and then 0 curly bracket. I could have also done curly bracket, like 1 curly bracket, and that would have also been totally fine. I could have done something like maybe curly bracket 0, 2 curly bracket, and that would have been adding 2 points in. But I just want to add 1 for now for the example. So the first interval looks something like this. So we go 0 and then tick marks. And the way this one looks is we start at -3, so 1, 2, 3, and then we fill it in. And then it goes to -1, not filled in, and then everything in between. And then let's look at that point. Points on real number lines just kind of look something like this. So we're at 0. It's just a ball, and you fill it in, and that's it. You're done. And now we want to union them. So unioning looks like this. Put some tick marks. Oops. We look at everything from both of them. So we put the point on because that's in one of them, and we also put this interval on the real number line because it's in one of them. And that's what the union looks like. Cool. We can also do slightly more complicated ones where we can do sort of union and intersection together at once. So for example, let's depict this monstrosity. I'm going to use square brackets to denote order for this. Don't get it too confused with the square bracket of the intervals. It's just kind of grouping them together with the associative property that we talked about. And so that's the intersection we're going to do first, and then we're going to union it together with, actually let's not do 0, we already did 0. Let's do 1, that is not the right, 1/2. Okay, so how do we do this? Well, let's take it one step at a time like we've been doing already. So let's do the first one first. Does that make sense? So this one in blue, so start at -3. Oops. Start at -3. 1, 2, 3. Open because it's a ball. And then it goes all the way to 2 over here. It's a long one. And that's filled in because it's a bracket. That's everything in between them. Ta-da! And then if we do another number line for the second one, 0, 2, 3, 1. We're going from 1 inclusive to 3 not inclusive. Perfect. And then we want to intersect these, right? So we're looking at kind of what is in between, what is in both of them at the same time, right? So if we look at this intersect in red, we get this endpoint inclusive and 2 inclusive and everything in between. Cool. Now we can't forget this part here. So we're going to come back down here. We're going to draw another number line, 0 and then some ticks. And we're looking at the point 1/2. So that kind of falls right about here. And now we're doing union. So we get to do everything that falls into either of them. So if we draw a number line, then we do this. The union, I guess I'll do blue again, would be this point here, because that's in this one, and this interval here, because that's this one here. And that would be the answer. Cool. All right, that is all for section 1.1. Let me know if you have any questions. You can email me. You're welcome to show up to office hours. I know that some of this is probably new material. Most of this is probably a review. So yeah, have fun on the homework.